Lesson 3, solving equations. We're going to start with some simple one-step equations. If I take question A as an example, 5x is equal to 20. In other words, 5 lots of something is equal to 20. In order to find out what that something is, I need to do the inverse operation, which is to divide by 5 on both sides. 20 divided by 5 is 4, so x equals 4. Now you may be able to work out in your head that 5 times 4 is 20 and get to the answer without any working out. However, it's crucial that you show the steps of your working, especially because we're going to rely on this balancing method as the questions get harder later on. I'm going to move over to the right-hand side now to these other one-step equations. We have x plus 3 equals 20. X plus 3 equals 20. Now I'm going to do the inverse operation again, and the opposite of adding 3 is taking 3 away, and I need to do that to both sides of my equation again. This gets me the answer x equals 17. Now you may be wondering why I have to do the same thing to both sides of the equation. So think of an equation like a pair of scales. If x plus 3 is on this side and 20 is on this side, and they are balanced because they're equal. If I do something to only one side of the equation, I'm going to be lopsided. The only way for me to remain balanced is to do the same thing to both sides of the equation. Now we're going to keep that in mind as we go forward with the next question. This one is a two-step equation, so slightly harder than the previous slide. I'm going to do an invisible, or not so invisible as it turns out, line down the equal sign. And the purpose for this is just to remind me that whatever I do to one side, I have to do to the other. Now, the aim of the game is to get the x on one side and some answer on the other. Now, I can see that my x is currently here. So I'm going to keep my letters on the left-hand side and my numbers on the right. So the first thing that I have issue with is this minus 3 over here in the wrong column. To get rid of a negative 3, I have to add 3, but I need to do the same thing to both sides. Now what I have left on the left-hand side is just 2x, and 9 plus 3 is 12. Now since 2 lots of x is equal to 12, the way to find what one lot of x would be equal to is to divide by 2 on both sides. That gets me the answer, x equals 6. We're now going to do an example, and we're stepping up again, so we're on to the third level up now. This example has unknowns on both sides. I'm going to start again with putting my little dotted lines down the equal sign to remember to keep both sides balanced. Now, in the previous example, the x was only on one side, and I knew to just leave it there and move the numbers away from it. However, in this example, I have x's on both sides. So how do I know where to move which one? The true answer is, it doesn't matter. You can move the 6x over to the 2x or the 2x over to the 6x. Either way, you can arrive at the correct answer in the end. However, my hint is always move the x's to the side that automatically has more. If you think about it like, for example, if your mum or dad was to call you, wouldn't you go to them? Because they're your mum or they're your dad, they're your parents. And so you would go to them out of respect. If we apply that to the workplace, if you were employed and you were working and your boss called you on the phone and said, I'd like to meet you, your boss isn't going to come to you. You are going to go to them. So think about the x's as, powerful. So we have 2x over here on the left, but we have 6 on the right. Now 6 is bigger. It's more powerful. It's the boss. It's the parent. And so the 2x will go to it. And the reason I recommend that is because it keeps the numbers positive and ends up being less work in the long run. So I'm going to subtract 2x from both sides. When there's no sign in front of a term, we assume that it's positive. So now I just have 20 equals Now 6x minus 2x is 4x, and I've still got the minus 12 over here from the original equation. Now I want to add 12 to both sides because I'm trying to get rid of the numbers. And that leaves me with 32 on the left-hand side and 4x over here. Now, if 4x is equal to 32, the way to find x is to divide both sides by 4, and we have x equals 8. Now, to just write it a little bit more sophisticated, we're going to just swap them around, x equals 8, so that we have the subject on the left-hand side. Okay. I have copied and pasted my example on the left-hand side, and you should use this example to now have a go at your own question. Feel free to look back at my example as much as you need to in order to help you to reach your answer. Okay, so just to go through this quickly, hopefully you would have established that the letters are going to be in this column and the numbers in this one because 10 is greater than 7. So you're going to subtract 7t from both sides of the equation and you're left with 3t minus 19 equals minus 14 over here. Then we're going to, that's not very clear, is it? Then we're going to add 19 to both sides of the equation in order to get the numbers on one side. And I have 3t equals 5. Finally, I divide both sides by 3. And you may have realized that you're going to end up with a decimal number. Now, you can either leave your answer as 5 over 3, or you can write it as a mixed number. 3 goes into 5 one time with 2 left over 3. And there's your answer. Now this question levels up still. So far we've done one-step equations, two-step equations, we've done equations with unknowns on both sides, and now we have unknowns on both sides and expanding brackets, so pulling in from prior maths knowledge. First we need to expand the brackets. 2 times x is 2x, and 2 times minus 3 is minus 6, and that's equal to 3 times x, which is 3x, and 3 times 1, which is 3. Now, because 3x is greater than 2x, I'm going to move the 2x over to the right-hand side, and I do that by subtracting from both sides. Now I have minus 6 is equal to x plus 3. I need to minus 3 from both sides in order to get x on its own is equal to minus 9. And of course, I can just reverse their positions for more sophistication.